Awesome. Hey guys, welcome back to the channel. So I know we haven't finished the sorting algorithm series. We still have to do heap sort and merge sort, but I don't want to do heap sort right now because I feel like before doing heap sort, I first of all have to do a whole video about the heap data structure so you guys would know what heaps are. And frankly, doing an entire video about a whole data structure is quite involving. You have to do things like read operations, write operations, how to get things into the data structure, how to get things out of the data structure. And you'd have to deal with complexity analysis like amortized time. So my point is, it's going to be involving, and frankly, I don't have the time for that right now, so we're going to hold off on the sorting algorithm series, and we'll kick it off later with heap sort and maybe merge sort. But don't get mad because we're going into another series that I call LeetCode Easy. Yeah, couldn't find a better name for it. So in the series, we're just going to solve a bunch of easy questions on LeetCode, and I feel like this is going to be a really entertaining series because easy questions on LeetCode can be really easy, and they're going to make you feel good about yourself, and you're going to feel like a competitive programmer. So my point is, they're motivating, and if you're just starting off with LeetCode like me, the last thing you need is something that demotivates you. So solving a bunch of easy questions would, get you into the LeetCode spirit. So to kick off the LeetCode Easy series, we're going to start off with a question called valid parentheses. All right, so valid parentheses. So this question gives you a string of parentheses and brackets, and you should return whether or not those parentheses put together are valid or balanced. So take, for example, we have an opening parenthesis, we have a closing parenthesis, and then we have a curly bracket, and then we have a curly closing bracket, and then we have a straight opening bracket, and then we have a closing straight bracket, right? All of these parentheses put together are balanced, so we should return true for this because we have opening, close, opening, close, opening, and close. But say, for example, we had, let's say, an opening straight bracket here. This is not valid. We should return false for this because we have opening, close, opening, close, opening, and opening. This should be closed. So how do we solve this question? Well, to solve this question, we're going to use a data structure called a stack. And frankly, you can use any data structure that allows you to get the last value that you put into it. So say, for example, something like an array list would do just fine. But stacks are specifically designed for these kinds of stuff because they follow the last in, first out principle. That's a LIFO principle. So LIFO. So that means the last thing that you put into the stack is the first thing that you're going to get access to at any point. So what do I mean by that? Let's say we have a stack, right? And we have two items to put into the stack. This is a really ugly stack. Awesome, that looks better. So let's say you have two items to put into the stack. And you put in item 1. And then you put in item 2. And then you want to get something from the stack. So at any point, you're going to get access to the last item that you put into the stack. That's this item right here. So this is going to come in really handy when we want to match parentheses, opening parentheses with closing parentheses, and mark them as valid. So yeah, let's go through an entire example to give you a better understanding. All right, so say we're given this string of parentheses and brackets, and we should return whether or not this is balanced. So we have our stack right here. This is our stack. And then we're going to iterate through the entire string of parentheses. And whenever we get to an opening parenthesis, we add it to the stack. And if we get to a closing parenthesis, we check if the last value in our stack corresponds to the opening parenthesis. And if it does, and then we remove it, we mark it as valid. If it's not, we do nothing and we keep adding. It's going to make a lot more sense when we do an actual example. So let's go through this one. So we get to the very first parenthesis. It's an opening parenthesis, so we add it to the stack. And then we get to the second guy right here. This is a closing parenthesis, so we check the last value in the stack. Does it correspond with this guy? Yes, it does. So we remove this guy from the stack, and by removing it, it means we've marked these two parentheses as valid. And then we're at the third parenthesis, and then it's it's an opening parenthesis, so we add it to the stack, add it, and then we get to this guy right here, closing, and then if it's a closing parenthesis, we check if it matches the last value in the stack. So we do like stack.pop, and then we get this value, and we check if this guy matches this guy, which in this case it does. So we remove this, which means we're marking these two parentheses as valid, and then we get to the fifth guy, that's a straight bracket, and then we add it to the stack because it's an opening bracket, and then we get to the final bracket, it's a closing bracket. So whenever we get to a closing bracket, we get the last value in the stack, which is this guy. If it corresponds to the current closing bracket that we're looking at, which in this case it does, we take it out from the stack. So remove this, and we're done. So at the end of everything, all we have to do is return whether or not the stack is empty. If the stack is empty, it means that all the brackets and parentheses matched, and if it's not, it means that there was a few brackets or parentheses, there was like one or two that didn't match. So let's say, for example, right, we had an opening straight bracket here, which definitely this would be false because we have opening and opening, and then we're here, we added an opening straight bracket, and then we get to here, and then what did we see? We saw an opening straight bracket. So what do? We add it to the stack. So now we have two items in the stack, and now we get to the end of the string, and then we say, oh wait, there are still items in the stack. So if there's still items in the stack, it means that we did not find corresponding closing values for those items, which means that those items are not valid. So we return false. So that's pretty much it for this question. Let's dive right into the code. Oh wait, let's talk about the time and space complexity, because I'm changing the structure of my videos now. I want to talk about time and space complexity first before diving into the code. So for time complexity, we're iterating through all the values in the string. So that's going to be an O of n time, where n represents the number of elements in the string. And for space complexity, we have a stack where we keep track of the opening curly braces, the opening brackets. And so for that, space complexity is going to be also O of n, because take, for example, what if we had a string of just completely populated with opening parentheses, right? We're going to go through all of them and decide this is open, 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 and then add all of those into the stack. So we're going to get at a maximum n items in the stack. So that's it for time and space complexity. Let's dive into the code for valid parentheses. All right, so the first thing we want to do is to map closing brackets to opening brackets, so we'll know which closing bracket corresponds to which opening bracket. So for that, I'm going to use a hash map, and I'm just going to map strings to strings. And then we do map.put. For closing curly brace, we have to map it with an opening one. And then we do the same thing for the other parentheses as well. So we're done with that. And one thing I like to do is to just make a string of all the closing brackets. So I just call it closing. And that's going to be this, this, and then this. And then do another one for all the opening brackets. And that's going to be, so this is opening, yep. Let's all say opening. So what this is going to allow us to do is to know whether a particular character is in opening braces or closing braces on the fly without actually knowing what particular character that is. So let's say we have like a parenthesis, like a closing parenthesis, and then we say if closing that contains character, we don't know what character that is. So if that returns true, we know that's a closing character, right? So let's go through all the characters in the string. I is equal to 0. Okay, I is less than s.length, I plus plus. And let's get the current character. Let's say string current is equal to so now that we have current, we have to check whether current is opening or closing. So let's say if closing that contains curr, it's closing, and then else we know it's opening. It's an opening car. So I don't even feel like we need this, because if it's not closing, it's definitely opening. And this might be something you want to ask your interviewer, depending on whether or not you're sure that you're only going to get opening and closing characters of parentheses in the string. So you might get something like an underscore. So it might be an edge case to clarify. Awesome. So I'm going to take out this because we don't need it. And now if it's closing, what did we say? We want to get the very last value in the stack and determine whether or not it corresponds to the current closing value. So now that I realize I don't have a stack, so we're going to create a stack. And that's going to be a stack of strings is equal to new stack. Well, let's take care of the case if it's an opening character, right? If it's an opening character, we just do stack.push. And what are we pushing? We're pushing current. If it's closing, we do we get the character without actually like popping it out. So we can do something like peek. So we can do string current. Let's say last is equal to stack.peek. And then we can say if last dot equals, and this is where our map comes in. So if stack.equals map.get, and what are we getting? Current. If this is the case, we can do stack.pop. So if this is not the case, then we do nothing, and then we keep adding the other characters as well. So at the end of everything, we just want to return a Boolean value depending on whether or not the stack is empty. So return stack.size equal to 0. I feel like you can return stack.isEmpty too. Might give that a try. So that's it. I'm just going to make sure that we have everything. Hopefully I did not forget anything. All right, so this has to be s.length referenced. All right, cool. So that's it. So if the first character that we got is like a closing character, and we're trying to get an opening character from the stack by doing stack.peek, and it doesn't exist, because you can't really start the parentheses, you can't really start it with like something closing. So that would be a slight optimization that we can do. So if we ever encounter like a closing parentheses and there's nothing in the stack, you might just return false right off the bat from here. So let's do that. So if closing that contains cur, and then we can say if stack that is empty. If this is the case, then we just return false. Because you can't start the combination of parentheses with a closing parenthesis. So run. Let's submit this. Oh my god, this is really embarrassing. I didn't put the other guy. Yep, that's it. Curly closing bracket, run, and yeah, so submit. All right, so this is really embarrassing. I haven't solved this question in 8 months, but I know where the problem is. So remember I said if the character we're currently looking at doesn't match, we don't do anything? Well, I was wrong. So if it doesn't match, it means it doesn't match. So we should return false. False. And let's run this with this test case. I keep failing all the test cases. All right, let's submit this. Hopefully it's accepted. Oh, cool. So yeah, that's it. Let's submit this one more time to raise my acceptance rate. So that's it for this video. I hope you learned something from it, and it kind of gives you a feel of sometimes you know how to solve problems, but then it's been a really long time since you last solved it, so there are certain things that you can't quite remember. But if you already know how to solve the problem, you can, figure it out. So it's always good to keep your LeetCode skills fresh, even if you already went through that interview and you already got that internship, you already got that entry-level position, you already got that senior-level position. It's always good to keep your interview skills fresh, do some LeetCode here and there. So yeah, that's enough ranting from me. I hope you liked this video. I hope you learned something from it. Like, comment, subscribe, and then share this video around the community, and I'll see you in the next one. Bye-bye.